And we are live with our 112th episode of Absolute AppSec. I'm Ken Johnson at CK Tricky on Twitter, joined by my co-host, Seth Law at Seth Law on Twitter. Seth, say hi.
Hey, everybody. Welcome back to another episode. And actually, Ken, it's number 113.
Oh, is it? 113th episode of Absolute.
It's like he can't even count. I don't know. I don't know what we're doing anymore. Right?
Not that high.
We're really excited to have Jacob on today. We're going to talk threat modeling. There's a couple of housekeeping items, though, that we're going to get to first. We have Midwinter Nights Con that's coming up. That's going to be December 16th and 17th. Correct, Ken?
Yeah.
All right. Yeah. And the sign up form for the links and everything will be up shortly within the next couple of days, as well as the schedule. We've got a whole bunch of talks and speakers that are out there we're super excited about. In addition to that, Ken and I are doing our next level bug hunting code edition training for Black Hat. I believe the dates on that are 7th and 8th. It's like the week before Midwinter Nights Con, right? There's a couple days there that we'll be teaching secure code review, how we conduct secure code reviews. If you're interested, please register. We'd love to have a good contingent there. And yeah, outside of that, I don't think there's any other announcements. Am I missing anything, Ken?
Midwinter's Black Hat. No, I don't think so. No, should be good.
Should be good. Okay.
Mm-hmm.
Well, good deal. Before we get into threat modeling, there was one thing that came up this week that I did want to talk about. There was a link that popped up, and it went around some of the Slack channels that we're in, right, Ken? And it was this whole low-cost freelancing penetration test. And I just wanted to get your opinion on it because I had all sorts of fills that came out from this, right? So basically, this guy went out to, it almost looks like an Upwork style freelancing website. Like, I don't know which one he used. Said, I have a penetration test that I need done, and then paid people anywhere from like $20 to $400 to look at a login page, right? That he had built a number of like 2 different vulnerabilities and then he analyzed the results of this. Now, I know I have a bias when I look at this and when I come to this situation because I'm in the consulting space. Like, we do penetration testing or application assessments day in, day out. But I wanted to get your take on, number one, how we went about like creating this penetration test and this study and what your thoughts on that are. And before I give mine, and Jacob, you can jump in on this as well. Like, you're in the space. But I posted that link. Did you? Here, I'll show it for a second.
Yeah, I'm looking at it now, reading it. The link is in both Slack and on YouTube.
Yep. Yeah. So, I mean, what is your thought there, right? As far as, hey, I've got an intentionally vulnerable page, and I'm paying penetration testers to come after it, right? Like, I know this has come up before in our personal discussions, but I don't think we've ever talked about it on the podcast.
I mean, yeah, like I'm just clicking through the reports. There was one, the $100 one. I didn't look through. Let me look for. So they had found cross-site scripting, clickjacking, absence of CSRF tokens, XSS protection. So it was like headers for $100. Sure, it's great. I mean, it's not indicative of for $100. I guess you could do worse. Let's see here.
I paid a lot more and maybe got different results than that. So I'm wondering, for 400, seems like they got their money's worth. But
didn't find the second bug on the $400, but like you said, you've spent a lot of money, and so if you just break it down to like dollar to vuln conversion rate, not only by the amount of findings but the severity, $400 is not that bad. I mean, once again, it's like, what are you going for? I don't think it proves anything other than you can get lucky, or I mean, it doesn't. I wouldn't say it's a conclusive. I like that he did it because this has been one thing that's come up a lot is like, so whenever I've been on a panel it always seems to come up like how much should I be paying for an AppSec test, for instance, or a pen test? It comes up on every panel. Have you done any panels where this has come up, or have either of you, like, because this comes up for me and I'm like, well, it depends. It depends on what you want tested. It just depends. It's hard.
I feel like if you're having a conversation about cost reduction on this, you're probably not going to have the outcome you're looking for. You don't need to pay through the nose, but if you're trying to like save money on your pen test, I'm worried about that.
Mm-hmm. Yeah. I think, I don't know what was the point to just show that you can spend a lot less and
still not find the bugs.
Yeah.
I'm not sure what the penetrate. I'm just going to the summary. Not surprising that you guys will do skills of freelancers. Okay, so he was just evaluating freelancers and then looking at the difference in the tests.
Right.
What's your thoughts, Seth? Because I just don't think any of this surprises me all that much. I mean, a lot of these didn't find. Most of these didn't find. The only one that there was actually only 2 that found one of the critical bugs. The $40 test and then the $400 test.
Maybe what's interesting here is the skills these folks claim to have. That's kind of interesting as I'm reading through each profile, what they have and then what they didn't find.
Yep.
Yeah.
So like I have a really hard time with the whole, like this feels like a CTF exercise to me as opposed to an actual like penetration test. And like I also don't like this whole, hey, we're going to catch the testers out idea, right? And I know that wasn't necessarily what he's going for here. He's just like, hey, there's these people on this, this freelancing platform to claim to have these skills. Let's see what they can actually find, right? So like on the one hand, I'm like, hey, this is kind of an interesting study of what's going on within these freelancing platforms. But it's also, you kind of get what you're paying for in this situation, right?
Yeah.
If you're going to a freelancing platform and looking for a top tier, manual penetration test, guess what? No one's going to do that for $40, right? Even $400. Right. I'm like, yeah, most likely they ran, they looked at the site, they ran Burp Suite, they dumped out the results, and, they maybe poked around for 10, 15 minutes and then called it good, right? This is like, that's what you're going to get. Well,
they probably could have made more in someone's bug bounty for the same bug for $400.
Yeah, exactly. Right. Like an XSS bug on any bug bounty platform is going to at least yield you $400, if not more than that. Right. So it's it's an interesting exercise. I have a hard time figuring out what he was trying to, what the point of it was, right? Like why he went about doing it. And I know, Ken, you were going back to the summary on it. It just elicited a lot of interesting, for me as a consultant, like running a consulting firm, I'm like, oh crap, like am I doing the wrong thing, right? Is this going to completely undercut my value? And like we kind of had those same fills when bug bounties started taking off as well. As like, is what I do still, does it still provide value? And it did like reaffirm that, right? As far as like, okay, this whole measured approach that we take when we're doing a code review and an application assessment, right? You're not going to get that for this, this low cost. So I don't know. I just thought it was interesting. It popped and it went around those Slack channels. Some people were for it. Some people were against it. And so I wanted to know what everyone's take was. So appreciate you guys entertaining me on that one. That's great. So, but we should introduce Jacob. Yep. Go ahead, Ken.
There is one thing. They said that they received all of the penetration testing reports a few days later. Well, man, wow. That's amazing. Like for that price. I mean, dude, it takes weeks to get these reports from companies. Like that's within a few days just for that alone. Good job. No, I don't know. I mean,
props to every one of those guys.
If you guys want to do this, go this route. If it feels good to you to do this, fine. If not, come back when your shit's all messed up. And, well, whatever. It doesn't matter. It doesn't matter to me, to be honest. I don't care. You do what you. If you want a $40 test, get a $40 test. Whatever. So yeah, back to Jacob.
Yes.
Let's talk a little bit. I'm going to give you everyone your background real quick. So so Jacob's last name is Salassi, Jacob Salassi. We met you in 2017, I think, AppSec USA. Was it 2017?
I think it was 2017, maybe 16, but one of those years.
Right.
Whatever year
yeah.
you were there.
Somewhere around there. Yeah. I think it was
Yeah.
2017.
I think it was. Yeah.
For Bay Area.
That's right.
Global AppSec. And so are you now a cloud security architect at Snowflake Computing? Or do you still do a little bit of both AppSec and cloud, or how's that work?
That's a funny title I have. So I'm at Snowflake, but although let me just go ahead and preface this by saying this is not a description of how Snowflake operates. I'm not representing anything we do in an official capacity, but I'm here to just talk about what we do, right? I want to make that clear. But in any case, we do a lot of things that are similar to this, if you get me. So yeah, at Snowflake, I'm actually the senior manager of the product security team. I started as the cloud security architect, and without sort of getting into it, I think at that time, we didn't really know what we needed, and so that was the title that I had. But what Snowflake needed me to do was scale a software security program for them, and so that's ultimately what I've been focused on. And we don't just think about the software; it's the posture of the whole Snowflake product, so the software and the infrastructure together. And so that's what my team and I work on a day-to-day basis, and making sure that, hey, developers and everyone else can operate in a secure way as they extend that system. Kind of a typical answer there, but yeah.
And you have a pretty lengthy background. I mean, I was looking at your sort of your history, and you were at Citrix for like a decade, and you've done the thing that's interesting is you've done a lot of software engineering and security. So you've done a good blend of, I mean, really, like you come with a really solid, it looks like, software engineering background. And it's like it's always nice when you see somebody who does AppSec that has that background, because you know that like there are so many bases that you've got covered, from understanding just like the other from understanding your engineering department, what they're doing, what's going through their head, and what their priorities are. So, and I did post a link just now to one of the tools that you wrote, the materialized threats, and was mentioned in Clint Gibler's TLDR sec. I think it was like number 46 or something like that. So, but yeah, like I'm excited to hear from you, because you're, we know you're knowledgeable, and we
right on. Let me tell you a little bit about, I guess, sort of how I came here, because the software engineering thing actually happened in the middle. Where I came from was network engineering, actually, and it kind of started way back, way back at a good old intersection of like evangelical Christianity and Whereas. So in my early church days, we had like a really small scene, and we traded like VHS games and other stuff, and only like the most holy stuff like Doom and Commander Keen. And so like at the same time, I was introduced to viruses, because I was the recipient of like many infected disks. Kind of got into MUDs. IRC, that's where, the precipitous decline started. I made it to FNet and kind of settled into that 90s, 2000s scene. Shout out to NetFiend, Sudo. Anybody remember MTV's True Life, I'm a Hacker? Good stuff.
No,
anyway, check it out, Ken. It's going to blow your mind. It was all a sham. Anyway, I had been working since I was 16, at that point, and was just trying to break into tech. And I had done some desktop support jobs, but like I said, I sort of started when I landed at Radware, supporting load balancers. And somewhere around 2005, I found the Dallas, the DFW InfoSec scene. So 2600, DC214, DFW Computer Security Group, a bunch of great guys and girls. I joined an IRC channel, had this crew around me, and we were just sort of challenging each other 24/7, 365. And in retrospect, it was kind of a ridiculous hustle and a lot of pressure to produce. And maybe you guys came from a similar place, but like we loved it. And I don't see people really doing that same thing now. And I think people are a little bit less willing, like, to put in the time after work, because of sort of the pressure that maybe they face at work, and sort of wanting to separate what they do at work from what they do at home. But for a lot of us, there's no difference. Like we did the same thing at work that we did at home. So, during that time, I picked up x86 exploitation, but I wasn't working on those things. I was doing network support. We played a lot of CTFs, Smash the Stack, Over the Wire. We went to DEF CON, did a couple of events there, got into hardware hacking. And that's what led me initially to C programming, right? I'd never touched any code really, except for MIRC scripts at this point. But it's about at that point that I moved from Radware to Citrix. And that's where I started getting my opportunity. I was supporting the NetScaler load balancer, which was implemented on a custom FreeBSD kernel. So like during that time, I'm building up this x86 exploitation skill set. I'm reading all these books, Deep Sea Secrets, design and implementation of the 4.4 BSD operating system, my favorite book. The art of software security assessment. Anyway, and what I really noticed at Citrix was that we get a lot of core dumps. And, all those skills sort of radically intersected, right? I was getting core dumps from x86 systems. I was learning assembly. I was learning C. And I just started to see like, hey, you can provide value beyond like, hey, here's a core dump developer. Take a look at this. Like you can dig into that and start to look at those things. And so maybe like by now what you'll notice is I didn't talk about college. I didn't really do any of that stuff. It was like, I did 2 years of community college and it just wasn't my deal. And I was already used to working because I had been working since I was 16. I was like, let's just continue to work. And as I worked with more of these devs, what I realized is that I knew networking better than them and that C wasn't really magical. And I had a really tough conversation with a dev where I was sort of explaining low level like networking to someone who was designing and building a high performance networking system. And I was like, okay, I could write the code here. And so then I kind of decided I would. And it wasn't super easy, but like I taught myself through that scene that I came through and networking and all of this stuff. And, I sort of taught myself, I networked, I got the job I wanted, and it helped that I have ridiculous work ethic. And I don't bring this up to like brag on myself, but to everyone who didn't go to school, doesn't know how to code. I see people asking this all the time. Like there's a Shia LaBeouf video, like just do it, like make your dreams come true. That's all you got to do. Like, just do it. People are always asking me like, how'd you do it, Jacob? And it's like, well, I read the book and then I took the next step and the next step and the next step. That's the biggest barrier for a lot of people. Anyway.
I will say that I have this, it's weird timing that you bring this up because over the weekend, I've been trying to do a lot of homework because this whole, like, in a very brief nutshell, the whole Zoom thing where we're the teachers kind of, or at least a teacher assistant with our kids, it really highlighted some things. So I started doing some homework and just to like give a real quick synopsis, like for gifted students, and gifted is such a misnomer because it's good and bad. There's some good aspects. There's some really also difficult aspects of learning. Like a traditional classroom environment will not work for a gifted student. And again, this is not I'm not saying gifted isn't in like an egotistical way. There's like, that's
right.
Actual criteria. Anyways, long story short, they are self-guided learners by default with intellectual pursuits. This again, I did a lot of reading this whole weekend and that's normal. Like, so I guess what I'm trying to say is if school is not for you, it doesn't mean that there's something wrong because it's not for me. It was never for me. It doesn't mean there's something wrong with you. You may be just a person who's better at self-guided learning. And that doesn't mean there's anything wrong. It's just a different style of learning. In fact, if anything, it can be a very positive thing, but there is the downside that it's very hard to concentrate in class and a lot of other things. So anyways, on that point, that makes total sense that, you were better at self-guided learning.
I was. And what I would say there is like, if that's you, then you do need to compensate with the social side of things. Like it is going to be harder for you because you won't have that stuff on paper. But like what I realized is like, okay, here's the survival trait I need, like people skills. I don't really like people. That's why I didn't go to a lot of DEF CONs. But it's like, hey, this is a skill I need to have to succeed. So anyway, ultimately I came and I joined this R&D team in Citrix. I got the opportunity. We were on a maintenance team, and really this was a really critical part of my career. As now we start to talk about like the AppSec part of things, because like as a software maintainer, I ultimately realized like the futility of this pursuit. You as a maintainer you don't write the code, you don't design the code, you just show up and you're supposed to just fix the bugs. Very similar to what maybe AppSec people are doing. Like that never happened. We didn't have enough context. We just barely enriched the data set, and then we sort of patted ourselves on the back. But like our metric of success was, did we deflect bugs from reaching developers? And we didn't most of the time. And I sort of was like, why do we do this? But I worked as hard as I could in that role anyway. I got picked up by the team whose code I was maintaining. And then we got into like my software development background. So, I got my shot, right? I got to this point and now they're like, hey, Citrix was pivoting from on-prem to cloud. It's like, hey, let's move NetScaler Gateway and make it a cloud-based, service. We'll facilitate access to our, Zen app and Zen desktop. I don't know how familiar you guys are with that offering, but we essentially became the data plane for a hybrid cloud like app hosting service. Citrix moving all of their stuff into the cloud.
Okay.
And what I realized at that point was, right, like, you know, what it was we had built on top of a complex FreeBSD kernel code base, no docs, no comments, no tests. And it was like at that moment, as I was responsible for like moving this from this on-prem thing into the cloud, I was like, oh, we've sinned like completely. And this is a huge mistake. Like, this is the sin of software development. At the same time, there was like this agile transformation going on in a push, but we got a test framework, and I learned, like, you need to write tests. Like, you should take this seriously. Like, you need to know what your software is doing. So anyway, I sort of persisted in that craftsmanship mindset, made it to principal engineer, and it was good. You know, I was really liking that job. Actually, I had a lot of fun there. But a good friend of mine from the DFW scene bumped into me on IRC, and you know, we realized we were both in the Bay. He was leading security at a healthcare startup. He knew I had been in the same kind of journey, this background, and he was like, hey, you know, last time I talked to you, I think you were doing kind of software dev at a high level. And I was like, yeah, you know, I got this role here. It's great. I really like it. And he's like, well, I need someone to start an AppSec program for me. And I think I need someone with a software engineering background like you. And, you know, he and I had, you know, rolled together in the scene on IRC for a long time. So he knew my background. Like, I think I need a dev like you to come in and start this thing for me. He's like, will you do it? You know, all along I'd been like, sure, I'd love to get in security, but I'm a principal software engineer. Like, I'm not going to start at the SOC or do whatever else. Like, how do I pivot? And this just became that opportunity. And I jumped on it, and it was insane. And I have all the gray hair I have now as a result of that. But it was a good move in the end. And so, you know, I left the job at Citrix. I joined them over there. I really learned the difference between like a 10-year enterprise stalwart type of job to like an insane healthcare startup. But the thing that I learned was like a team of trust and safety, and like that magic number of 3. There were 3 of us together, and it was just us against every threat actor, you know, that was potentially interested in this healthcare business. And that was like really serious, and it weighed on us heavily. And that made like a big impression on me. And so, you know, eventually things happened. We needed to move on, but that kind of that bonded us, and I still keep in contact. In fact, work with 2/3 of those people today. But that's where I really like started my journey. What I learned there was like, there's some problems with software security, with application security. And what I did, you know, to begin with was spend like a year researching, right? I was like, okay, I know generally what we need to do, but like, let me just go read the whole world of application security. What are people doing? So, you know, every variant of SDLC that everyone's written, MS-SDL, you find Threat Dragon, you find security champions. You start reading, you know, Omar Levy's stuff about threat modeling as code, you know, Izar stuff about threat modeling as code. You eventually stumble upon threat modeling research that compares various, you know, so I just looked at all of this stuff, and there was a lot of good stuff out there. And what I sort of concluded at the end was like, there's a lot of good ideas here, but nobody's like says exactly how you should do it. And no one said, how did it turn out? Specifically security champions. Like, no one wrote the story about like, how did my program turn out at that time? In fact, if you read like the security champions playbook, I think there's more slides that end in question marks than there are with like statements about what you should do. So that's sort of like,
I'm one of those people that tried up a security champion, and it didn't go where I thought it was going to go back in 2011. Yeah. Well, and that's what, you know, one of the things I'll sort of tell you about that. So we tried it at the first place and had sort of mixed results. And as I got another shot at it when I joined Snowflake, I had a much better idea of like what I wanted to solve. And a lot of that was like, you know, what exactly are these deliverables going to look like? How are we going to make them something that doesn't just go into Confluence to die? How do we make it live forever? Like the code, how do we make threat modeling really like code? This is ultimately what it came to. We're producing a bunch of documentation artifacts. We want developers to own them, but we still produce them in this sort of arbitrary format. You know, it's on a whiteboard. It's on a Confluence page, it's on a wiki, but it's not next to your code. And like the code gets a commit every day, every week, right? That lives, but your documents kind of die, just like your design documents die around the outside of your code. So we also knew we wanted to get it close to that. And so, like I said, I sort of wanted to be the person who would figure this out and maybe write the story about how it worked, or at least, you know, be able to do it for the current place. And so we sort of looked at a couple of sets of problems, which were like, hey, you know, threat modeling maybe has a couple of canonical problems. And it's like, you want developers
to adopt it. And the problem is that, well, what are the goals of threat modeling? You ask them, well, what's your threat model? This is probably my favorite question in security. What's your threat model? I just ask people that just to hear the different answer, not because they have a different and interesting threat, but I'm like, but how do you actually document that? Like, what did you actually put on paper and what did you put there? No one had a good answer about what that actually was.
But did they know what a threat model was to begin with? I mean, I assume there's some context that you had given around like, what is a threat model? Or you were just like, what's your threat model? And just see what you...
This is something I would hear actually in podcasts, like not necessarily this one, but security podcasts and in security conversation in general. You would hear people kind of hotly say, well, what's your threat model? Especially when someone would start like speculating about a particular threat. And so I started to wonder, like, well, what is that? Like, let me Google threat models. Like, what does that look like exactly? Like, I don't know. What's my threat model? Well, I don't know. Like, I can tell you things I'm worried about. Is that a threat model? You know what I mean? And that's all I felt like.
No, I do. I do.
Hand waving. And so I was like,
it is. Yeah. It feels a little bit like that at times.
Right. Yeah. So I said, well, what are the goals are not clear. It has no formal definition. It doesn't have any structure. The methodologies are super vague. They're more art than science. And most people will say that threat modeling is art. It's not a science. Yeah. And I'm like, that's hard for developers to reason about. They get stale.
Especially when you want to make a systematic, repeatable process.
Right.
Yep.
So, and then the tools. So this sort of comes back to my other research. Like I hear people talk about Threat Dragon. I don't want to hate on that too much, but anyone who said they uses Threat Dragon didn't use Threat Dragon. Like you can't use it. It's not usable. It's not a thing. If you're in a Mac shop like I've been for 2 years, it seems so ridiculous, but you can't use them as threat modeler. Sorry, like you can't. It doesn't run on a Mac, and you're not going to run that VM. Trust me. Like no one will use that.
We tried running it, and I think it did. Yeah, we came to the conclusion we couldn't use it in its current form. Not that it's like just throw it away, but it was just like there will have to be changes for this to be usable.
Right. So I guess without getting into like why do developers need a threat model? Like they need to because you'll be a bottleneck, right? And you want to scale. And so you need developers to own security. And like Manicode said it, we all know it, like engineers own what they produce, own the security of what they produce. Like that's sort of a foregone conclusion. And so now the question you need to ask yourself is like, okay, cool, developers need to own security. Well, how much of it do they need to own? What does that look like, right? And so then we said, okay, well, what is it specifically about threat modeling that's challenging for them? Because they just don't know what that is. It's not many people do not perceive that to be a software engineering practice. There's a quote that I actually took from this podcast. I'm trying to remember who said it, but it was software engineers are great at drawing diagrams and telling a story. And they are good at that. And so what we wanted to do was have a strategy that leveraged strengths, right? If they understand how to draw diagrams and telling a story, you can sort of up-level that from an engineering perspective and say, well, you know how to create diagrams and model systems, right? That's what you do as a software engineer. You describe your systems. And so what we felt like they were not equipped with formal techniques to model threats, right? Threat modeling versus modeling threats.
Yeah.
And so then what we started to say was like, look, what's the point of you doing this? We want you to model threats against your design so that we can enumerate design-specific security requirements so that we can have a security test plan. And there's not just design-specific security requirements. There's many security requirements. We have domain-based security requirements. We have technology-based security requirements. We have, just functional requirements that also come from those categories. But ultimately, what software engineering is about is, in some senses, gathering requirements, and then building a way to continuously assert that those requirements are being met. And security requirements are just one subset of that. And in fact, maybe they shouldn't be treated too distinctly from those other things. And so now what we wanted to say is like, okay, cool. The goal of threat modeling for a software engineer is to produce a security behavior test plan. Like we want to agree on a set of behaviors the system should exhibit. And this should include sort of what the threat and the mitigation is. And then we should have a way to continuously test that. Now, coming back to some of that earlier research, threat modeling as code, a lot of people talked about using Gherkin. And what I liked about Gherkin was that less that it was BDD and all this stuff, but that it used like natural language to describe requirements. So many stakeholders could now consume this thing. And in some future world, you could wire it up to a test framework. So it had nice line of sight. And ultimately, this is what we sort of put in front of developers. We said, look, if we want you to analyze your design for security threats, and then we want you to document those as behaviors for your system, like any other behavior your system has, and then we want to assert that those behaviors are true, just like the rest of your test plan. So So I guess, you know, the goal of threat modeling, or rather the threat modeling is a process by which engineers analyze designs to identify the set of design specific security requirements and then produce a test plan to continuously test those behaviors. And so, you know, for us, another thing we thought about, or one thing I noticed about threat modeling was like, why do we keep talking about behaviors? Because a lot of people would do a threat model and they would just have like a list of threats. Like, I'm worried about this happening. I'm worried about that happening. Like, this could be vulnerable to XSS. Well, so what? Like, well, what should it do about that? And so we felt like it needs to be this behavior that, you know, and Gherkin was convenient for this. It's like, given a condition, then these other things should happen. So you could say, given the threat scenario, then these other things should happen. And now we start to talk about, like, okay, we have these two pieces and these two ideas. Like, how do we now put this on Rails for a developer? And it's about this time we encountered, you know, what we were doing was essentially stride per element. We would come and just apply this model to stride per element. We're like, hey, do a DFD. You can do stride per element. And what we're going to do is, you know, have a standard output. We were happy with just having a standard deliverable that we could check into a Git repo. That helped us deal with, like, hey, security said, that kind of stuff. You know, we felt like that was good, but it was still pretty burdensome. And then one time I you know, through this research, I encountered this rapid threat model prototyping process. You guys probably would have encountered this at least once before. Jeffrey Hill at Tudomantic came up with this. And I saw this and, you know, initially I didn't know what to think about it. I thought, this is interesting. Let's play with it a little bit. So we started to play with it internally to see, like, okay, does this work for us when the team internally is doing threat models? And we're like, yeah, this is good. This is easy. It makes it easy for us. It produces the same amount of threats. And really what we wanted to do, I guess, to sort of summarize this whole thing, we wanted to reduce the burden, like the cognitive burden of coming in and like thinking about stride. What we want developers to do is to come in and just say, hey, like, what could go wrong? And this is what many people talk about when they talk about threat modeling. They say, what can go wrong? But we felt like you need to provide a set of boilerplate to developers so that they can get to the point where they can safely themselves just ask what can go wrong. But we as security engineers can be confident that they've like covered the set of common issues in between, or that 80-20. And that's sort of what RTMP is about. It's, you know, with 20% of the effort, you can get 80% of the threats. And so we looked at this as a way where, like, bam, we can now turn stride into boilerplate. And then we can sort of free the developer from having to think too much about how to generate the boilerplate and just let them think about the threat. So we brought RTMP into our process. We made the way that stride per element occur very deterministic. And then what we said was, cool, we can automate this too. So what's happening in the background, guys, is now we're getting this huge collection of all of these Gherkin threats described in a standardized markdown deliverable. We can parse these, like, for each security review. We can go in and we can say, okay, what were the threats? Grab the Gherkin out, store them up. We have all of that data. Meanwhile, we're like, cool, we found a method that developers can follow 6 rules. If they follow these 6 rules, it'll produce the same output every single time. And really the only art then is, can you draw the diagram correctly? And we thought, look, developers know how to draw the diagram. There's going to be some nuances there. We can optimize it to produce more threats than less threats and kind of deal with it that way. But it was on Rails. And so we said, cool, well, then we can automate that too. And that's sort of now, Ken, coming to where you left it off, which was materialized threats. So we, you know, the whole time, there's like many pieces here that were MVP that could be automated, but we knew one of the key things to automate were the things that the developers did most often. And what we were asking them to do most often was perform the threat model and produce deliverables. So we wanted to lower the bar to being able to do that. Now, another sort of interesting thing, and this is very specific to where I work at Snowflake, you know, Snowflake is a data warehouse. Everything we do is built on data. You know, a big passion of mine had been like, I guess ultimately what Simmel did, CoQ. I'm not going to claim to have come up with that idea. I didn't. But perhaps at the same time, we were thinking like, could we load enough information about, you know, commits or something else, like meaningfully query the database and understand something about it? And then we started to think about, well, what about these threat model deliverables? Like, if nothing else, we want to be parsing these and storing them in the database so that we can start to build up a risk profile around these applications. And then when RTMP showed up, and like, it just kind of clicked. I was like, oh, we can think of this as a graph, a property graph. I've been playing with Neo4j. And to see if we could automate RTMP, I've been playing with Neo4j. And then I was like, okay, I sort of vaguely understood property graph, understood it enough to say, hey, we can do the same thing on a relational database. And then that's sort of how we implemented it. We said, okay, there's 6 rules. We can take now, I guess to sort of back up, we standardized on draw.io for the reasons I mentioned to you guys before. Microsoft Threat Modeler, off the table. Threat Dragon, not useful. But draw.io, super useful, and Key has an offline mode, so we really like that. It happened to have some threat modeling shapes. You know, I did the research, so everybody would have encountered draw.io and the threat modeling shapes at some point. And so what we said was like, cool, let's figure out how to just parse these diagrams and just make a pitch to the developer. You developer, if you can show up with just a DFD, I can produce for you an entire feature file of boilerplate stride-based threats and like shells of threats. And the reason we can do that is because with RTMP, you can say, for example, and I don't know how familiar people are with this. I sort of have my notes pulled up to the side here so I can talk to you guys a little bit about like what are the rules. But essentially, you know, if you, sorry, give me just one second to pull this up here.
Oh no, yeah, I put a link for the
yeah, you guys did put a link
for Jeffrey Hills. Yeah, I don't know if that's
right. No, that's exactly what it is. So anyway, at the end of the day, you know, you can run the rules, and so if you parse a flow, for example, trust 0. In trust zone 0 are things which you have no control over. So this is like very common. These are the web client, everything else. In trust zone 1, this is your whatever your entity is on the edge that receives the first thing. So if you have a flow which originates in 0 and extends into 1, then you have a series of threats that are associated with that. So spoofing is one of those, denial of service. And that's because the data is moving from a lower trust zone into a higher trust zone. Conversely, if you move from a higher trust zone into a lower trust zone, you start to have worries about information disclosure and things like that. And so with this in mind, you're saying, cool, just produce a diagram. And on the diagram, just, you know, try to do this zone annotation. Draw the diagram and put 0 on your sources and put 9 on your sinks, and then put something between 1 through 8 in between. And like the rules for how to do this are very specific. It's like 0 is the client, 1 is the edge, 2 through 8, who cares? Just kind of wing it. It really doesn't matter so long as you kind of get the gut feel of which way is trust going. And then 9 is where the data winds up. And from this, you can now produce this. So cool, you developers show up with this diagram and annotate it with these zones. And now we can just, it's XML. We can parse it. We can figure out, okay, cool, which zones were floating where. And now we can create a graph of what we saw in this threat model. And that graph stores a couple of properties. And that property is like, hey, is this an entity? What kind of entity is it? Or is it a process? And what trust zone was associated with it? And from here now we can just calculate all of the threats against it. So bam, you give me the diagram, I spit out for you. If you know Gherkin at all, like feature file is just a template. And we can say, cool, from 0 to 1, because data flows from 0 to 1, then you have a spoofing thread, and we kind of ... and that's boilerplate. Okay, and then what we say is, cool, from your boilerplate, we can infer now the names of your entities, right? People use the same names of their entities. So I told you guys, for a year, we'd been generating Gherkin blocks, right? Yeah. And saving them in right, saving them up. So now we can generate the boilerplate, and now we have a bunch of pre-existing stuff, and now we can just do token matching and say, cool, here's a boilerplate for you. So not only will we give us a diagram, we'll generate you boilerplate that says, here's the stride stuff you should think about. We'll also say, and here's the stride stuff you should think about that might be related to ones you've done in the past or ones other people have done in the past. So now we're trying to get them to auto-complete their boilerplate. So this is essentially what we tried to build with. It's 2 tools. It's called Materialized Threats and Pickle Hog. For whatever reason, that's what we called it. But
Pickle Hog.
Yeah. And yeah, that's sort of what we tried to do. So that was to automate essentially the same process, right? A developer can manually do this today. They get the diagram, they put the zones on it, and their brains operate the 6 rules, and then they explode out the stride threats on it, and they annotate those. Instead, we said that's obviously on Rails. That was the point, so we can automate that for you. And then what we said is, you've also been generating for us all of this value in design-specific security requirements captured as Gherkin. Like, let's make sure that we can suggest as many of those to you as possible each time you run one of these threat models. And that's where we just tried to be able to get like 80% of your boilerplate with even some boilerplate enrichment on top of it, like contextual boilerplate, not boilerplate that you're going to have to completely refill out. And that's sort of to get to that point where, like, what frees the developer to just think about the system It's when you kind of can generate all of this other stuff for them and suggest as much of it for them and let them go through it, then let them kind of sit back away from the boilerplate and just think about what do they care about. Then they can come back to the boilerplate and kind of think, did we miss anything? And that's how we can catch that. That's how we think about trying to catch that other 20%. That sort of is not necessarily, if you say we're going to do 20% of the effort to get to 80% of the threats. So we ask them to do maybe now like 5% of the effort to get 80% of the threats because we automated it. And then we say, cool, now just focus on that remaining 20%. Do you need to talk to your security partner? Do you want to talk to my team for a consult? Or maybe you're good and you're consuming secure defaults. There's sort of a lot of other apparatuses around this that either prevent you from entering the threat model flow in the first place because you have enough risk mitigated and we're good with your security requirements, or ultimately you enter the threat modeling flow and start to go through this kind of a process. And so that anyway is how we approached it. And I guess to sort of sum it all up, what we don't try to do is have developers like boil the ocean. We want them to take an approach that takes your design, generate a set of relevant contextual security requirements for your design, put them in essentially what resembles a test plan, and then have you write those tests. And that's what we want to do. And then we want to have peer review, and we want to have security partners come in and developers come in and like really wear that security hat to just think about what are the other stuff where they don't have to worry about, did I do stride per element? Did I do this? Those things are not exciting to them. So we want to do those for them.
So what? Oh,
sorry.
Yeah.
No, go ahead.
No. Okay. Yeah, I was going to ask. So, like, what has your success rate been? Because it sounds like you tried a couple different things with developers before you settled on this process, right? Like, you've got the Gherkin files you created. Like, are you seeing better involvement from the development community at that point? Or at this point, right?
So we had pretty good involvement throughout. I think what was really interesting about the opportunity here it was a very centralized review process. It was very painful. And so it was like very easy for me to make it much better for them. Mm-hmm. And then when you could sort of talk about like, hey, you own security. Now let me talk to you about like how you can think about this. So they had a lot of appetite. So really we just kept making things better for them, better and better and better and better. It's really hilarious. Like someone came to me in the lunchtime and was like, Jacob, I love threat modeling. I was like, as a developer on the apps team, like one of the teams we put the hardest, like they were greenfields, so we're like, you have to do everything. Like you have to go through all these processes. Like there's no, and they said like it was useful to them. And so anyway, for better or worse, I'm not saying like we made up dream threat modeling or anything like that, but we were able to sort of take advantage of the engineering background, right? There's so much to say about this topic. I'm not sure I'm saying everything. Like for me, it was really important to look at this as an engineer and be like, maybe it's a hot take, but I'm like, AppSec is not doing a good job because there's not enough software engineers in AppSec, and people are not making this concrete. You keep doing security to software engineers. Like you don't do security to them. Like security is a part of high quality software engineering. They're not two different things. And if you keep having to have a conversation about how security is different than quality software engineering, like you're failing. And so that had just sort of been my whole approach was like, let me just kill. In fact, the thing we're doing now is like delete every reference to secure development. It's not a thing. Like we don't even have a secure development handbook. There's just a development handbook. We try to get rid of every single reference to the word security when we stick something in front of a developer. So right, to answer your question, Seth, it was just to make things easier for them. What we led with here was risk assessment and making sure that you only needed a threat model when you needed it. And that's what helped us not like burn the mind share on developers wasting a lot of time doing threat models and not having them be valuable. The second thing we did was involve a member from my team in every single one of these threat models. So we would sit in the room and make sure that they were getting through it and make sure that like things didn't go off the rails and time didn't get wasted. And so what we've been able to do, the way we see success is like, how often do we have to do that, right? Uh-huh. And now where we're at now is like, we're not involving ourselves in threat models by default anymore. The volume of threat models continues to be high, and the quality, or rather the results of testing don't suggest to us that there's any problem with this approach. In other words, vulnerabilities are not going up.
What's your what do you give developers as their this is what constitutes when you should run through this threat model? Like what's the event that triggers them going through that?
Yeah, so it's pretty on rails. So we have like a fairly full-fledged project management type of system. So you have a project risk assessment. It's like, hey, is this thing so risky, we're going to need to do a penetration test and we need to manage risk to your timeline. So before you even commit the project, there's like a touch point, which says like, hey, have a consult with us. Like, let's talk about your thing and figure out what we're going to need to do for this one. That's sort of done at a high level pre-planning. Once planning starts, there is an individual feature-based risk assessment, and they're domain specific. So it's like, hey, if I'm in the cloud engineering team, you know, I'm making this kind of feature, it deals with this kind of use case. So use case based. And we say, cool, these are risky use cases. These are not risky use cases. And here's some ignorant questions that will guide you toward high risk. So you pretty much can't screw it up. You know what I mean? So where we don't have like a good question, we're just going to steer you toward medium or high, and then you're going to end up over there. So uniformly, we can feed everything in. And then it's really about now deselecting as rapidly as possible. Once we funnel everything in, we want to be able to quickly get to the ones that are really low and move them out. And what that really mostly involves is us iterating. And that's where we got more of these domain specific feature or rather risk assessments, right? Real quickly, teams start to complain that, hey, this is not relevant to me. And you're like, great, that's exactly what I want to hear. Like, what's the question we need to ask? And then we just started iterating all of those. And we have this thing called the golden triangle, where we would say at the top is low, in the middle is medium, and at the very tip is high. So we really make it clear to people, like, you only do the most expensive review for the smallest amount of things, and try to help them understand we want more things to become low risk. It's not that we don't want to review things, it's that things should be getting lower risk over time because we build secure defaults around them, because we understand them better. We can document a requirement. We can assert a requirement through static analysis. We can replace that with a secure default and then assert that through static analysis and these kinds of things.
So is that an automated, that's some sort of like a questionnaire that they fill out on that?
Yeah, that's right. So it sort of went through two phases. I talked about how the whole thing was essentially markdown in a repo and a lot of copy of pasting of markdown into various places. And then where we saw developers cry the most, not cry, but, you know, express frustration because they're going to, like, we knew that this would be painful, but we knew that each part was parsable and that we would be able to automate whichever part was the most painful first. And so, right. For the risk assessment, initially we took GoSDL. I actually wrote a tool to rip GoSDL to Markdown, and then we would put the Markdown and then have them copy paste that into Jira.
This is what I've been saying. Everybody's piecemealing. I mean, maybe built on top of something like GoSDL, but that's what everybody I talked to who's doing this first risk assessment, then threat model, if it makes sense. That's what everybody seems to be doing, is building their own stuff on just to make that work. You know, it could be Google Forms. It could be, like you said, building on top of GoSDL. But, and that's the interesting thing, is that there is a distinction, and you're making it very clear, I feel like, in this podcast, between the risk assessment, which is like, does this even warrant going down the path of a threat model? And then the actual threat model, which is totally different and is based off of, like, in this case, developers going through it, but, you know, usually in some shops it can be a mix.
Right. And then there's that third dimension where we're coming in and testing it. So people might start saying, like, dude, where are you doing like the real security? And it's like, right, we get the risk up front. We know what it is. We let the developers do their thing. We get the signal about risk, and then we come back in and add the value we need to add to make sure it's good. If it's high risk, we're going to really pen test it real hard. And if it's low risk, you know, we're not. And so, again, like, we don't, I don't want people to think we lose the value of threat modeling. Like, there are security people who are doing threat modeling, like we all think about it, but that is not what developers need to be doing. Developers need to be getting test plans written that make sure that, like, the things we agreed upon, the secure behaviors for this system are, one, enumerated, understood. This is like requirements gathering, period. It's a problem for all requirements in all software. In security, just one more requirement that can be poorly understood. So making sure that those requirements are well understood, contextual, and then, like, testable. We want to make it as easy as possible for them to just consume that requirement because it's already out there in static analysis, or there's already some secure default, or we're only suggesting to them the requirements that are really relevant. Like, I think an interesting anecdote is here, ASVS. We tried ASVS. One, it's not really a web shop, but two, I'm sorry, 0 developers cared about ASVS. Like, 0 of them.
No, I don't believe that.
There was no way that we could present it to them, and we wrestled with it. And we're like, you know what? We just cannot show them anything unless it is Snowflake specific, period. Like, just do not bring it up. So we really backed way far away from it. And now what we really focus on, and also because we're not a web app shop, like, it's just not. It's database systems. So we just try to build up this big value extraction machinery. Like, that's all we want to do, is, like, plug into developers, give them a little bit of juice, and then drain it all out of them, and, like, figure out how to repackage that and circulate it back to them. Because we knew that they had all of the They knew what to do securely. They knew better. We go and ask them, what are your security requirements? Like, how are you building these things? Now, let me just build a value extraction system around this. However you best capture them, however your team expresses them, like, okay, cool, we're going to try to standardize the fact that and you can come and tell us things that you do. Cool, this is how you should express them. Does this make sense for your team? Are you expressing them? Now, can we measure how many you've expressed? So you started talking about how we do risk assessment. So originally we started with this Go SDL variant that was just like a copy paste job. Now it's really about these use cases and security requirements. And so what we're doing is we're saying, cool, these use cases have these requirements. How many of these have you met? What's the residual? How much of the risk? You assess it once. The risk is what it is. Then we say, cool, here's a set of requirements that mitigate that risk. How many of those have you met? Do we even know how many requirements should be there? In other words, what's our confidence in the set of requirements, and how many of those requirements have you met? And now we can calculate a mitigated risk score. And from here, that sort of has been evolving, right? We get better at assessing that front end risk. It becomes more and more contextual. Less and less flows go into threat modeling because there's more secure defaults, more security requirements that show up over time to mitigate more risks, which we've already encountered, if that makes sense.
It definitely does. Yeah, like I've mentioned it a few times, but I think like what's interesting is folks that use not only questionnaires and information drawn upon from developers, but also like some automated tooling such as App Inspector that profiles the behavior of an application to kind of help also further guide the and this is the thing, like I feel like developers are really good. Well, at least whenever I get on the call with the team, usually most of the team's pretty good at like understanding their own risks. It's just that they need to go through the exercise. Like what you're doing is forcing them to like think like about that specifically. And once they start down that path, I feel like most engineers are really like, oh man, we're pushing this plain text data onto this, in memory stream. Well, yeah, maybe somebody could read that, or maybe, hey, maybe we're putting, like there's all kinds of.
It's not too much to ask either, because they're reading about very complex performance problems, and it's like, oh, this subtle way we're manipulating this data has these downstream effects, and you're telling me like you can't think about the fact that that data is outside of your control. Like, that's not true. This is just another part of your analysis. And again, the problem, it's like an empathy thing, man. They can't hear it when you describe it to them as a security professional. Like, you just have to spend all of your time being like, aren't you a software engineer? Don't you do these things? Isn't this the same? Until finally they're like, yes, it's exactly the same. And then we just tried to subtly change the language from threat modeling to modeling threats. Like, just don't call it that, because they don't know what that means. But they know what modeling is, and they know what threats are. And it was like a subtle change.
There's this missing piece I was going to mention, Seth, where it's like we've talked about how developers should own security, how like security is just part of development. But what we haven't talked about is that developers should not be also then making decisions on accepting risk or not. That's where it gets weird. Is there's that little ground there where it's like, security, but we got to get this shipped in a month. What risks are acceptable? And that gets another layer more complex, but I suppose your threat modeling material helps with that.
It does, but we have a full-blown security champ. I mean, we don't call it champions because those are volunteers. We have partners. There's at least one partner on every single team. It's like a 7-to-1 type ratio. Once it gets bigger, you got 2 partners, 3 partners. So those security partners, one, are like cherry-picked. All of the best top engineers on the teams, usually, like that's who we ask for, who has strong design skills, who has visibility into all of the projects, and then like, you must give us one. So that's where that tier is. And like, we spend a lot of time, like everyone does, developing that community, being close to that community, like they're a part of the team, and making it safe for them to wear the security hat. And you got to walk that line. Some people wear it a little too proudly, but it's okay. Like, just wear it and feel free to, like, we're going to make it safe for you to raise these types of concerns. We have like a twice weekly acceptance meeting where developers are presenting in front of my team and security partners their threat models, and then they need to be accepted. And it's at that point we get another opportunity to rate. Did you miss this? The security partner gets a chance to say, did you miss this? And there's not, we try to remove that perverse incentive from the developer themselves, but we know that that's not, entirely possible. So we add another check in terms of the security partner. You don't have perverse incentives. And then, we either attend or audit. Of course, there's some sample size where we're comfortable saying, look, we've sampled N number of these and we've agreed with these. And that's the other thing about all of these assessments. Each of them, a compliance person, a security person, or a developer can read them, right? And if you're engaged genuinely, you get the same output. So they're auditable in that sense. Every one of them is deterministic, and like the use cases are specific enough where you can, even the compliance auditor can look at that and say, okay, was it one of these cases? So then we can know, like, what's our error rate? How many people are escaping without really engaging in the process? So sort of between all of those factors, we have the fundamental check and balance. We don't like to leverage that. We want to just really, at Snowflake, we have a strong engineering culture, a strong security culture. So we try to lean into that as much as possible and just try to make it safer and safer and safer for developers to own this and, work with leadership. I won't get into all of that, but like, that's a big thing is like leaders understand how do we make sure that at the end of the quarter, when we're talking about performance reviews, like how are you making this real for developers so that I'm not just asking them do more work, but your manager's not talking to you about this during performance reviews, right? So all of this kind of thing.
100% agree. It needs to be part of the job description. It can't be like this, like, oh, because it feels good and like I'm doing the right thing, which is great and that's wonderful, but it's not realistic.
You're forcing them to choose. You're forcing the developer to choose, and like that's the thing. Anytime, and ultimately, there's always some choice that's going to be made. And so again, that's why you have peer reviewers and other things. But like, the less you can force them to choose between like their perceived goals, their manager thinks they should ship the feature faster. No, like they should perceive their manager wants it done securely because all of the other reasons. And that's how we try to go for it.
Yeah. And I don't think, to be clear, security should own the risk either. It's what you said. I think an engineering manager and above needs to take that full picture. Security needs to be real. This is the point too. Like security needs to be realistic about, assigning real risk to things and just not being like, there's a balance between paranoia and where reality exists. And you have to like lay it out very clearly. I think this is why written and verbal communication is so important, because you have to take something that's going to be described to probably 4 other, at least, managers, right? Especially if it's a showstopper, like the risk is too high. We have to make a decision here. Yeah. Then it might delay us. Then at least 5 other people have to like translate what you're writing, what you've written and said into like a decision-making process. But I don't think it's security. I don't think it's because like you said, you're trying to empower them to make these decisions without being, if something goes wrong, it be their fault. And that's a perfect example is you do need to like lay it out and then just bring it up the chain and let them make a decision and then just be at peace with whatever happens,
Yeah. And I think that's where like, having good data is important, being able to really, it has to be real for the teams. They have to be able to, you have to empower them to hold themselves accountable, just like you said. And that means you need to give them the data about how they're doing. And then, like you said, we do sort of, it isn't, right? And that's a big thing. It's like you development teams, you own this. Like, we're not here to cognitively offload security for you. A long time people would say like, oh, Jacob reviewed it, it's good. Or, my former colleague reviewed it, it's good, right? That's the full cognitive offloading of security. And I'm saying like, no.
Right, I agree with that.
I don't own that.
Well,
like, I'm going to.
Yeah. And that's what honestly, that's what I run into from a consulting perspective.
All the time,
like,
I'm sure.
All the time, right? Like, is it like you walk in and they ask, you guys did the threat model on this. So that's all we need to worry about, right? But stepping back from that, right? It's that whole compliance check where they offload the risk. They're offloading security to a third party, even though we have really no skin in the game outside of that like short window, right? And so even as a security team embedded, right? It's
the fundamental futility, right? You can't know enough to have accepted that responsibility. Like you can't. And so really no one is accepting responsibility for anything. And then a couple of security guys get axed in the end. Like, what's the point of that? We didn't achieve anything.
Yep.
So,
Well, how many times, Seth, have somebody come back to you and been like, even when you have given them everything, you've laid it out, how many times has someone been like, but can you change that from a critical or high to like
to a
low or a medium? Not even a medium, a low, So some auditor doesn't classify it.
Well, I try to be flexible about that kind of stuff, right? Those kind of requests, because if it is a security team And it does, like, I'm like, okay, this is how I rate it because I've got this small scope that I'm looking at. Like I did this,
Right.
my own little mini threat model of this application. And when they come back and they ask that, I'm like, okay, talk to me about mitigating risk, right? Like talk to me about other things that are in place to give me a justification to do this. But realistically, this is the report. You can do whatever you want with the ratings when you pull it into Jira or whatever you have, right?
Right.
But
Yeah.
it happens every single time. Like it's almost every single assessment that I do at this point, right? Like even those that yeah.
You're kind of trying
we're
to
moving off from
care
threat
about security risk. No, but I just mean like
Yeah.
this is another super hard problem. Like getting people to care about security risk, not security controls or risk to controls or like risk to the business. And like I was having this conversation with a coworker. McKinsey's written an article about like the death of, or rather what I would call like the death of maturity models and the success of sort of quantitative models. And in the McKinsey article, what they're going to show, and what every business leader who reads this, and I encourage them to, is to see like in a maturity model, it might cost you, 14 million to do something because all you know is that you're just trying to get to 3. But if you were actually quantitatively, or at least just thinking about risk to the business and really approaching it that way, we'd have a much different outcome because we would choose not, and probably many security pros would be shocked at the things you would choose not to do because, the risk is not necessarily where you think it is.
Oh my God. Dude, that you just described it in bug bounty programs in a nutshell there, just so you know.
Right. And so I think the challenge here, though, is like with all of you guys, right? There's a lot of businesses who just, and because security teams also have sort of failed to make it real for them in terms of business risk. Like we just, oh God, vulnerability 0 days. No, like, let me talk to you about annualized loss expectancy. Like, can you finance, would you like to see this? Then people start to care about what you're talking about. And we try to bring that same thing. We're making decisions that direct millions of dollars of engineering man hours when we say do a project this way or that way. And it's like, how confident do you want to be? Would you just like, because I think so. Like, let's, let's do this many layers.
Not quantified.
Because, right. And then
it's also,
go ahead.
No, I was just going to say, it's also scary because there's another component, which is you trying to make decisions about how your users or organizations I'm just users. Like you might be building in controls that allow them to further reduce their risk. This happens a lot with my work in building new features and things. It's like you have to consider what they might want. And that's where I find it to be the hardest is like, just figuring out like what controls people have to have and what controls, meaning like literally they can do these options and check these boxes on a web app. Right. And, make those.
Well, what's interesting to
changes.
think about is a web app might not be a business success if you put in the security controls you want. And then should you have done that? And you shouldn't have, plainly. Yeah. Right? Like it just doesn't make sense. And so again, like for us, trying to talk about like security empowering business goals, like that's our just fundamental attitude. It's like we're not doing for us, it's nice, it's a feature as well, but like if it wasn't a feature, we'd be having maybe a little bit of a different conversation about like how far we were going in various places. But because of where we are and who we operate with, it's like you said, expectations. Customers have expectations, and then the business has goals. And what we're trying to do is manage risk to those goals, not just arbitrarily increase security. And I think the same thing's got to be true for the developer, right? It's nice to say that for the business, but for the developer too, you should be optimizing for the outcomes of what this feature needs to do to be successful, right? That doesn't mean that the feature should be extra risky, but it does mean that if like your mitigation impacts, critical performance parameters, like you have to be able to reason about that. And you have to be able to think about alternatives that are going to allow the system to meet its performance requirements.
Preach. That's what I'm saying. This is what I deal with every damn day. So
I think if everybody pick this book up, Engineering Trustworthy Systems, I highly recommend this. Like for every security pro who read Security Engineering from Ross Anderson, like read this book. It really puts it in modern terms. Like this is what you need to be doing, and I highly recommend it.
I'm gonna put a link.
Cool. We'll drop a link to that for sure.
Yeah.
Because I'm with both of you on that because I don't feel like we like, and this goes back to the whole Jacob, what you were talking about with developers and application security, right? Like it's always been my, like for the last 15 years, I've been saying developers make the best application security professionals, right? Like You want to find somebody who's good at AppSec, find a good developer.
Right.
Don't try to take your security principles and force it down onto the development team, because it all goes back to this kind of same discussion, right?
Right. And this is even like leadership skill. Exactly. You're right. Exactly there. Like people, so many good books, but like you want people to make their own frameworks. You want people to suggest their own things, and you want to just tell them what you heard and give them what they want, because they all really know. And like, if you can just get past your egos and like, don't waste time, just engage genuinely with people. Developers care about what they do. You might run into one or two who don't. That's okay. Talk to the ones who do. Give them what they want. You can have a reasonable conversation about like what needs to be built. But if they're not driving it, then like you're failing. You're doing it to them, right?
Yep.
You can't do it to them.
Yeah, you can't. I like that idea. You can't do security to developers, right? They're the ones that are in charge.
Well, and for Jacob, you mentioned that you had a certain set of developers and people that you worked with, and as your career shifted to different places, some of those folks you still work with, and that is so true. I work with developers now that I worked with at Living Social back in like 2011, 2012 timeframe, and the longer you do this, the more so the decisions you make, I 100% believe that it's what you're saying. You can't talk at them. You can't make it like, you're not trying to put together a talk you can put at a conference, and try to, you need to be real about because you're going to be working with those folks, whether you like it or not, probably it's going to come back around for sure. And you're going to meet them again. And you really do have to establish and maintain a relationship with balance, because it is it's very difficult. Because sometimes I think I've mentioned in the last month, sometimes it's like it's easy to also go the other way and just be like, you know what, I can see your job's really hard. You're working late hours. Maybe this thing's not that important. And then you like kick yourself 2 days later, like, man, I got to reverse this. And that causes further friction. So it's anyways, it is. Don't try to talk at people. Don't try to make it like, it's about them and a mutual relationship, for sure.
That's right. And I remember you guys, we had the little Twitter kerfuffle about should security engineers be writing code? And it's like, well, if you're an AppSec, how can you have empathy for what a developer does if that's not what you do? Like, and I'm telling everyone on my team, you better be able to do like 85% of what they can do. Not because I think like you have to write code for arbitrary reasons, but like that's what they do. And you're designing things that are supposed to integrate with what they do, not what you think they do, right? Like what they actually do. And if that's not something you're familiar with, then how can you expect to really integrate with what they're doing? And so I think it's an unrealistic expectation. And from an empathy perspective, you're not setting yourself up for success because you don't understand what's going on.
Yeah. I mean, honestly, like if you want to understand what it is to be a software developer, go pick up one of those bugs that you just handed to them and go fix it in the code. Because that can be a 2-hour thing, or it could be like a 5-week thing to actually fix some of those vulnerabilities. It's not an easy,
and you have to write
it's not all configuration. Yeah, exactly.
Because you're going to get feedback. You're going to make changes, and you got to rerun. You got to update. Yeah, that PR could sit there, like you said, for 5 weeks as changes are made, and it's something that you thought was simple is not. And it affects somewhere else.
You guys know deadlines are tough. It's tough. I've written code, like 72 hours straight to meet them. And like, you need to like think about the fact that somebody might be in that situation, right? And like, what did you do before then to make them successful rather than just show up at hour 71 and be like, by the way, this is blocked. Nobody likes that guy.
Yeah. Yep.
I know.
Interesting. Well, Jacob, we want to be cognizant of your time too, right? Like this has been a very interesting discussion, but we have been going we're about 10 minutes over, the hour that we normally promise people, but it feels like we could go on and on for sure. Moving from threat modeling into other things if we wanted to.
But this is why you should, at some point in your career, do blue. Obviously not the people on this call, but I'm talking to the viewers. This is why you should do blue teaming, because you're going to get a very different perspective and do a lot of different things that you wouldn't necessarily look at the same way in consulting. And then it will make you a better consultant should you inevitably go back to consulting.
Yep.
Yeah. Really good.
But so Jacob, any last thoughts, right? We've got the books, we've got some links, people check out, like where can they find you if they have questions or they, want to further have a discussion with you about it?
Yeah, well, that's an interesting question. InfoSec Twitter is what it is. So, you could DM me, but don't expect like a ton of engagement. I'll answer DMs and stuff like that. So that's fine. No, I think like the things I just want to tell security folks and everyone else sort of what I said. One, I think everybody needs to get educated on quantitative risk assessment. Like, I don't think that I wonder how you're solving the fact that you're, hand waving. If you're not doing this, if you're not really analyzing risk and doing engineering for security, like how are you doing that? Maybe the second thing I would tell people is, like I said, when you think about what software developers need to do, I think often people fall into the trap of thinking that security partners and software developers own all of it, or that security partners need to be doing, they do all of the threat models on the team or whatever. It's not about just like lazily shifting left. It's about shifting it everywhere, and it's about dissolving security. Like, you need to dissolve security into development, not bolt it into various places. And I think a lot of people misunderstand that part, and then that's what causes developers to like not produce useful outcomes and long living outcomes whenever they do threat modeling or whenever they conduct security activities. The inputs and outputs of that need to be natural parts of the software development process. And if they're not, then I question how you're going to preserve that value.
Yep. Cool. Well, good. Yeah, that was a nice succinct kind of wrap up of what we've talked about today. We appreciate the time. Yeah. I mean, at some point, we'll have to get you back on, and we'll see how things are going, like how it continues to progress over there at Snowflake. Sure. And but very interesting for sure, right? Like, I've got a bunch of notes, takeaways that I've got to think about when I'm going into organizations to help them like do this process. So and quick shout out to you guys. That deliverable, I pushed you guys to make a markdown deliverable. I think you put it in one of your repos. That became the genesis of every other deliverable I built in my security program. Like that thing we did in your class for that security review. I was like, hey guys, can we make this like a standardized deliverable?
That's awesome. That's amazing. Yeah, that first part of that whole methodology is like super important and kind of speaks to everything at least not everything, but it touches on some of the major aspects of what we're talking about today. So in terms of like behavior profiling and understanding risk. So
cool.
Great. Thanks, guys.
Cool. Sweet. Thank you.
All right. Well, thanks everybody for joining us today. We'll get this posted. Follow Jacob, follow us, jump into Absolute AppSec Twitter. No, well, not Twitter. Let's jump into Slack if you want to have an actual discussion. Twitter's Twitter, whatever. Anyway, Ken, any last minute thoughts before we close it out today?
No, just thank you for everybody who watched, and thank you, Jacob, for your time, because man, this hit home with me so hard. Like, this is literally my life right now. So amazing. It's great.
Thanks. All right. Thanks, everybody.
Bye.